This is an instructional video on using the Pythagorean theorem to solve for 3D shapes. For these problems, we are going to use a modified version of the Pythagorean theorem. We are going to change our a squared plus b squared equals c squared formula. Because this is a 3D shape, we have to have 3 numbers in the equation or in the formula. You can think of it as extending the formula into the a squared, the b squared, and the c squared to give you a final answer, which could be assumed as d squared. We're going to have 3 numbers in the actual equation. When we solve our problem, we are going to take all 3 numbers, our 2 edges, going straight up and down, and then going across the front as well, so 3 edges. And we're going to use that in our modified Pythagorean theorem version. The 13 squared going down, the 6 squared from side to side, and the 13 squared along the front. 13 squared is going to give us 169. 6 squared is going to give us 36. 13 squared is going to give us 169. We add them together, 169 plus 36 plus 169 to get us 374. And our last step is to take the square root. The square root of 374 is going to give us 19.33. Looking at that second decimal place, 4 and less, we round down. 19.3 is our D value, the diagonal line. There is a much more complicated way to solve the problem, but this is an easier method that will work every single time. Again, when you're trying to find the diagonal length that runs all the way through the middle, you take your 3 values. They represent your 3 lengths. 15 is here going up and down. 24 is our long side here in the front, and the 8 is the going backwards to forwards. It does not matter what order you put your numbers in. In this case, I'm doing 15 squared plus 24 squared plus 8 squared, which is going to give me the D squared value. 15 squared is 225. 24 squared is 576. And 8 squared is 64. We're going to add all those numbers together. 225 plus 576 plus 64 is going to give us 865. Last step of the Pythagorean theorem is to take the square root. The square root of 865 is 29.41. Looking at that second decimal place, 4 and less, we round down. So 29.4 is our answer. Each time we start by taking our 3 values representing our 3 sides. 15 represents the side length, the height, and the back. 12 represents our side length across the bottom going from the back to the front. And 35 represents our front side length across the bottom. We take our 3 lengths and write them in any order. It does not matter. I'm doing 15 squared plus 12 squared plus 35 squared. 15 squared is 225. 12 squared is 144. And 35 squared is 1225. Add all of those together. 225 plus 144 plus 1225 is going to give us 1594. Last step of the Pythagorean theorem is to take the square root. Square root of 1594 is going to give us 39.92. Looking at that second decimal place, it's a 2. 4 and less means we round down, so 39.9 is our answer. Stuart's friend wants to play a trick on his friend by hiding his pencil in the box of tissue shown below. If his friend's pencil is 9 inches in length, will it fit diagonally in the box of tissues? Explain. So because it gives us the word diagonal, we're looking at the diagonal in the box. And so diagonal of a 3D shape is your indicator to use the Pythagorean theorem using all three numbers. 4 represents our height in the back, 4 represents our side going from back to front, and 8 represents our length along the front long edge. It does not matter what order you plug your numbers into the equation. Any order will get you the same answer. 4 squared is 16, 4 squared again is 16, 8 squared is going to give us 64. Add those together, 16 plus 64 is going to give you 96. Last step of the Pythagorean theorem is to take the square root, and the square root of 96 is 9.79. Looking at that second decimal place, it's a 9. We know that 5 and higher rounds up, so that rounds up to 9.8. His pencil is 9 inches. 9 inches is less than 9.8. So when we answer the question is yes, his pencil will fit in the box. We always start by taking our three numbers, 12 representing the height on the back edge, 6 representing the bottom edge going from back to front, and 8 representing the length across the front. Plugging all of those numbers into a modified version of the Pythagorean theorem in any order, it does not matter. 12 squared is 144, 6 squared is 36, 8 squared is 64. 144 plus 36 plus 64 is 244. Last step of the Pythagorean theorem is to take the square root. Square root of 244 is going to give us 15.62. Looking at that second decimal place, it is a 2. We know that numbers 4 and less round down, 15.6.